Operation Lab 2, and today myself Amal will explain to you about the mixer settler. First, the introduction for mixer settler. It is used for liquid-liquid extraction, or also known as solvent extraction. For the second one, separation method to separate compound based on their relative solubility. For the process, first solvent are introduced in material, then as some components are more soluble than others, it starts to separate out. And finally, this allows the component more prone to dissolve to separated completely. Okay. And this is the diagram for the experiment. We have two tanks, the mixer and the settler. The objectives of our experiments are: we want to obtain the solubility curve for both water-rich and toluene-rich phase. And then we want to determine the tie lines connecting the binomial curve. And then lastly, we want to study the effect of stir speed versus the efficiency of the experiment. First, the result of the discussion. For experiment A, we have the toluene-rich phase diagram here. Then second one, we have for water-rich phase diagram, calibration curve. And then for experiment B, we obtain the point or the tie lines intersect at point R. And then for experiment C, we obtain the graph for efficiency of the stir speed versus the stir speed. Our error and recommendations. First, we had difficulty in determining the endpoint of saturation, so we had to use auto titrator. Second one, contamination may occur, so it's better for the fractometer, so it's good to clean it up carefully after uses. Then lastly, measurement of volume of chemicals. So what's the conclusion? The conclusion is the refractive index increases when toluene is present in heavy and light phase solution. And also based on the calibration curve, the lines were plotted and most of them did not intersect at point R. This may be because of the errors. And lastly, the efficiency of the mixer settler was shown to increase. So the efficiency increases as the stir speed increases. Thank you.
Hi everyone. Next experiment is CSTR dynamics. CSTR stands for continuous structure reactor. This is the picture of CSTR. For our experiment, we have two series of CSTR. Next, there are two parts of the experiment. The first one is effect of step change. This is the graph for step change input. Next, and the second one is effect of pulse. This is the graph for pulse input. Next, the objective of our experiment is to study the transient behavior of three continuous reactors connected in series by plotting the resistance time distribution curve. Next, this is the result for the first experiment. Next, this is also for the first experiment, RTD versus time. And this is the result for the second experiment. Next. In experiment A, a step change input is introduced and the conductivity values are recorded for 45 minutes. Based on the results, RTD is gradually increased over time. And for experiment B, a pulse input is introduced and the conductivity values are recorded for 46 minutes. Based on the result, the RTD are increased but then gradually decreased over a few minutes. The presence of air bubbles will disturb the flow of the solution into the next vector. Therefore, during the experiment, make sure that there is no air bubble track in the pipelines. As a conclusion, our experiments were successful in a way as all the calculation proved the theory was correct. This is Kami film evaporator. As an introduction, the Kami film evaporator is a type of evaporator that is essentially a vertical shell and tube heat exchanger. It is designed to operate as either a batch or continuous evaporator. There is a wide range of applications for residual evaporators such as production of polymers for production, pharmaceuticals, and solvent recovery. The objective for this experiment is to study the effect of evaporator pressure KMNO4 pressure against refractive index. And for this experiment, there are three sub-experiments. The first one is effect of evaporator pressure. Next, effect of evaporator feed level. And the third one is effect of evaporation time. A pre-experiment was conducted to find the relationship between the KMnO4 concentration and the refractive index, as you have seen in the first graph. For experiment A, the experiment is conducted to study the effect of evaporator pressure on the evaporation rate. Based on the results, it explains that the higher pressure optimizes the evaporation rate. For the second sub-experiment, it is conducted to determine the effect of evaporator feed level on the evaporation rate. At lower feed level, the time taken to form the first bubble and the time taken to boil is faster. Next, and for the last experiment, the experiment is conducted to study the effect of evaporation time of the evaporation rate. At lowest running time, the time taken to form the first bubble is the highest value, while time taken to boil is lowest. This is because less liquid is evaporated within short period of time. Error and recommendation: during collecting the evaporate solution is not exactly the correct amount because a few droplets might stay outside the tube. This can be solved by waiting for all the droplets to completely out from the tube. As a conclusion, from the result obtained in experiment A, it can be seen that as the pressure decreases, the time for first bubble and boiling point also decreases. For experiment B, we can see that as the level is increased, time for evaporation increase is faster. And for the third experiment, you can see that as the running time increases, the rate of evaporation increases. Thus, to get a better evaporation rate, all of these three factors must be considered in order to achieve perfect evaporation rate. Action.
Assalamualaikum and hi everyone, I am Hasika. Today I want to explain about the spray dryer. Spray dryer. For the introduction, material is to be dried in spray in the form of small droplets. Spray dryer involves three fundamental units process, which is liquid atomization, gas droplet mixing, drying from liquid droplets. And for the application is for drying soap and detergents. Next, for the objective is to study the effect of flow rate, air inlet and outlet temperature and RH measurement. Secondly, to conduct an energy balance, mass balance and the heat loss of the system determination to the pump. Okay, this is the result and the calculations. This is an example of calculation for experiment A, for experiment B, for the experiment C and for the experiment D. Okay, for the discussion, the dosing speed is the rate of boiling mixture being pumped into the system. First experiment was carried out at a dosing speed of 0.5 liter per hour, while the second experiment was carried out at a dosing speed 1 liter per hour. Based on the result obtained, we can see the first experiment yield double of boiling powder compared to the second experiment. The result with higher dosing speed, the rate at which the slurry is being fed into the system also increases, which may have resulted in a less resolution time. This is because as dosing speed increases, more slurry mixture will pump into the dryer. Therefore, more energy is needed to dry the slurry mixture in the system. For the energy balance, the second experiment consumes higher energy. For the mass balance, the value for the second experiment is double for the first one. And for heat loss, the heat loss obtained for the first experiment is higher than the second experiment. The recommendation: the heat loss in the experiment can be minimized by insulating the piping. Secondly, to avoid temperature from fluctuating, it is recommended to take a few readings and use the average value. And as for the conclusion, for the lower dosing speed, the mass of boiling liquid double compared to the higher dosing speed. For the energy balance, lower dosing speed, the rate of energy obtained is lower compared to the higher dosing speed. For the mass balance, for higher dosing speed, the mass balance is double compared to the lower dosing speed. And last but not least, for the heat loss, for the lower dosing speed, the heat loss is higher than the higher dosing speed. So to sum it up, lower dosing speed yields more products and consumes lesser energy. Thank you.
Go.
Hi everyone. For the next experiment is batch pack column distillation. For introduction, batch pack distillation allows the fraction of multi-component mixture into its pure constituent in a single column. The advantage is low chemical cost and easy approach method. The objective is to determine the high equivalent theoretical rate HETP at the total reflux condition and constant reflux. Next, this is the results for the first experiment. Okay, next. Okay, this is the result for the batch distillation at total reflux at the 100% heating power, 10, 80%, 60%, 40%, and 20%. Okay, this is the graph of HETP versus heater power, and this is the result for experiment 2 at constant reflux. This is the graph, and next. And for the discussion, from the result, the heating power is changes. Only at 100% heating power, the HETP obtains triples, while it keeps decreasing from 80% to 20%, the HETP value keeps constant, which is only 1 plate each. The equation of HETP is height of packing column divided by number of theoretical stages. Okay, for the experiment 2, the power of heater is set to 70%. So the flow rate increases with time as the concentration of ethanol in the product increases, while its concentration in the fluid gradually increases. The mole fraction of distillate decreases from 0 to 1.55 minutes and increases from 3.87 to 5.17 minutes. And the number of theoretical stages decrease for each interval, causing each ATP value to increase. The recommendation: before taking the sample, we should have let the temperature of the column to stay at a stable temperature. Secondly, the amount of sample taken for each reading from the column also need to stay constant. This will affect the comparison graph significantly. As the conclusion, for the first experiment, we concluded that HETP value is inversely proportional to the number of theoretical stages. The higher the HETP value, the lower the efficiency of the separation process. For the second experiment, we learned that as the flow rate increases, the composition of ethanol in the distillate stream also decreases, and the mole fraction in the bottom product decreases with time. Both of these changes is due to the distillation process. Next. Thank you.
My name is Mona. Moving on to the next experiment, which is RTD tubular flow reactor. RTD is determined experimentally by injecting a tracer in a reactor at time equals to 0 and then measuring this tracer concentration in the effluent stream. Some tanks and circulation pumps are provided as well as instruments to measure this tracer concentration. This is the figure of an RTD tubular flow reactor. Next, the objective of this experiment is to determine the effect of liquid and gas feed rates on mean residence time, and then to determine the degree or intensity of liquid facial axial dispersion. The results of experiment A, which is a step input for counter current mode, are following. For co-current mode are the following, and for experiment B, pulse input of counter current mode, these are the following graphs, and for co-current mode, these are the following results. For experiment A of step input of counter current mode, when the time increases, the conductivity also increases. This is because top feed is used for counter current, which makes the flow becomes faster due to gravitational acceleration. Next, for co-current mode, from time 1 to time 3, the value is 0 because the NaCl solution is still in two phase with the deionized water. After time 3, the conductivity value slowly increases because the NaCl solution and deionized solution are homogeneous and well mixed. Next, for experiment B, which is a pulse input, conductivity values recorded show that high values in counter current compared to the co-current flow. Because in counter current flow, the molecules of NaCl collides with the molecules of water with high frequency. Next, the error obtained in this experiment, the first one is the instrument is not fully rinsed. So we must make sure the tube is fully rinsed before using it. And the flow rate of water and salt solution are not constant due to pump rate inconsistency. So we must make sure to use an automatic flow rate controller. Next, we can sum up the experiment by concluding for step input, the conductivity increases as time increases. For pulse input, the conductivity increases until it reaches its maximum value, and after some time it decreases back, producing a bell-shaped curve, and the maximum value in counter-current mode is higher than in co-current mode. That's all. Thank you.
Moving on to the next experiment, which is spray drying. Drying is the process of thermally removing volatile substance to yield a solid product. The dryers are made of trays held in a cabinet which is connected to a source of heated air by gas, diesel or biomass. Next, the purpose of conducting this experiment are to investigate the influence of air temperature on the drying rate of a wet solid in an air at fixed velocity, and then to investigate the influence of air velocity on the drying rate of wet solid in air at fixed temperature and humidity. Next, these are the results obtained at experiment A, effect of temperature at heater point A. Next, effect of temperature at heater point B. Next, effect of velocity at velocity point A, and then effect of velocity at velocity point B. And in box, discussion part, in experiment A, for both temperatures we observed that the drying rate is at highest when the temperature of air is high. This is because heat energy fed into the system helps to dry out the moisture content. The major type of heat transfer that took place in the system was convection. For the experiment B, effect of velocity, higher velocity would yield a higher drying rate because as the velocity increases, there's an increase in volume of airflow through the pores of sand, which may play a huge part during the drying process. For the errors and recommendation, the water is sprayed on a certain concentration portion of the sand. So we must make sure that this water is sprayed throughout the sand so that every part of the sand is wetted with water. Some dirt and heavy dust particles may rest on the weight balance whose pen is placed on top. So we must wait for some time until no fluctuating is detected before taking the release. To sum it up, as the air temperature is increased at constant air velocity, the drying rate of wet solid will also increase because at higher temperature the wet sand will dry faster. Next, as the air velocity is increased at constant temperature, the drying rate of wet sand in air will also increase because an increase in volume of airflow through the pores of the sand. That's all. Thank you.